In this video, we are going to take a look at two different application problems and how you would approach them using quadratic formulas and equations of different types. So the first one here is going to be a rectangle problem. And so what we have is that the diagonal in a rectangle is 15 meters in length. And so what we would do is, using that very first sentence, I would go in and draw myself a picture of what is going on. So we know that we have a rectangle. So I would draw yourself a big old rectangle. And then furthermore, we know that we have this diagonal here. And we know that this diagonal is going to have a certain length. And that length itself is 15 meters. So I would draw in my little diagonal. Now granted, you don't have to use a ruler, but you could if you chose. And what we know is that this length is 15, and it's 15 meters. Now the other thing that we know is that we know the length of the rectangle is 1 less than twice the width. So when we're looking at a rectangle in general, we know the long side here is your length, and we know that the short side is usually your width. Furthermore, the problem told us that the length of the rectangle was 1 less than twice the width. So this says that our length is going to be 2w minus 1. And then the question wants you to find the length and the width. So the one thing that we don't know is we don't know anything about our width. So we'll go ahead and input our w's here. Now with that off to the side, we need to be able to know where to start. And the place that we start is with the formulas that we need. Well, first thing, I've got this triangle here, and the one thing I know about rectangles is that their angles are always 90. So this triangle here is actually a right triangle. Furthermore, I know right triangles have a very special formula which I can use to try and help me solve for the missing lengths. And that formula is a squared plus b squared equals c squared. In this place, or in this case, we would substitute A, B, and C for the parts that we have. So, for example, we could say that A was the width, make B your length, which would make C that diagonal. So once we know that, we can actually substitute in for the values that we've got and set ourselves up a problem to solve. So if we're talking about width, we are talking about this short side or the purple side. So here we would have w squared. Now when we're talking about our length here, we're talking about this long side. And so here we're going to add this to 2w minus 1, and we are squaring it. Now, the diagonal here was given to us as 15. So this whole thing equals 15 squared. So we've set ourselves up a quadratic. So now we simply need to start working on solving that quadratic. In this middle part right here, we have to FOIL. And the reason for that is because this 2 tells us that we have 2 of these binomials here. So this says we actually have 2w minus 1 times 2w minus 1. So when we FOIL, remember first, outer, inner, last, we are going to end up with 4w squared minus 4w plus 1. So we have to remember that this was what this middle part should reduce down to. So we need to add in the rest of our equation. So what we really have was w squared plus 4w squared minus the 4w plus 1 is equal to, and when we do 15 squared, we get 225. So now with this, we actually have to start solving our quadratic. And when we solve our quadratic, we need to remember a few things. First, we must be set equal to 0. So the first thing that I would do is I would take this 225 and I would move it over. And then I would combine my like terms by adding these two together. So when I do that, I end up with an equation that says 5w squared minus a 4w minus 224 is equal to 0. So what we have to do with this is we have to solve it. Now, because this value is so large, I would use your quadratic formula in order to solve it down. So here, what you need to do is we need to identify A, B, and C, and we need to set up our formula. So in this case, we have that your A is going to be 5, your B is going to be -4, and your C is going to be -224. So with that, we set up our formula. X plus or minus, is equal to, let me try that one more time. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we need to plug the values we have in. So in this case, we end up with negative of my -4 plus or minus the square root of -4 squared minus 4 times 5 times -224 all over 2 times 5. Now we have to start simplifying our problem down. So the first place that I would start is with the stuff under the radical. So I'm going to go ahead and we're going to take a look just at the stuff here under the radical, and we are going to simplify this down. Okay. So we have -4 squared, which is going to give us 16. Negative times negative is positive. And then we have 4 times 5 times 224 is going to give us 4480. Add your 16 to it and you get 4496 as a result. So let's go ahead and input that back into our formula that's now been reduced some. Negative times negative is positive, so this is 4 plus or minus. Now it's going to be the square root of 4496, and the whole thing is over 10. Now the next thing that we have to do is we have to reduce the radical. So in this case, we're going to look just at this radical piece, and we are going to reduce it. So we need to reduce the radical. So in order to do that, again, so we're going to look right here at that radical. So square root of 4496. And we're going to reduce it down. So first and foremost, I can reduce the easy way. I know I can pull a 2 out. And when I do that, I end up with 2248 as a result. Now at the moment, that doesn't work, so I need to keep going. I know I can pull another 2 out because the number's even. And when I do that, I end up with 1124. Now, if I look very closely, you can see that right here I have a group of 2 identical terms. So what this means is I can pull out the 2 out of my radical. So I am working very hard now at being able to reduce things down. This 1124 can reduce further. I know for a fact that I can pull a 2 out. And when I do that, I'm left with 562. Now, since this is still even, I automatically know I can pull out another 2. And I'm left with 281. So looking again very carefully at it, notice I have another group of 2 here, which means I have another situation where I can pull out the 2. Now when I look at 281, it's an odd number, so I can check, and when I divide by 2, I end up with 140.5. So in looking at this, I would be safe to assume that I have reduced down as far as I can go. So I would go ahead back to my radical and see what I've done. So in this case, I have 4 plus or minus. I am pulling out a 2, so I bring a 2 to the outside. I'm pulling out another one. I bring a 2 to the outside, and I'm left with the square root of 281. And I divide this by 10. So in this case, 2 times 2 is 4. So I have 4 plus or minus 4 square roots of 281. This whole thing is over 10. Now if I look, 4 over 10 and 4 over 10, this can reduce, because I can pull a 2 out of all of these. And when I do that, this becomes a 2, this becomes a 2, this becomes a 5. So here I have 2 plus or minus 2 square roots of 281 all over 5. Now at this point, what I have actually just solved is I have just started solving down for the width. And so this is where you want to be able to figure out which you're using. So here, if you remember, this tells us that we have x equals 2 plus 2 square roots of 281 all over 5, or we have x equals 2 minus the 2 square roots of 281 all over 5. Now, if you remember from the beginning, we have this little statement here that says round to the nearest tenth. And what that means is that we are expecting to get a decimal as a result. Well, we have to know which one of these values we're using and which one we're losing. Biggest thing you need to remember is that you cannot have a negative length or width. So in this case, I would be very safe to say that this subtracting side we're going to get rid of, which means we're going to be left with the positive. Now, you could actually check yourself. You could take the square root of 281 and then you could multiply that by 2 and then 2 minus that number, and what you're going to see is a negative. Okay, so here we need to actually find this value. So depending on the calculator you have is going to make a big difference. The calculator that I have here is this TI-36X Pro. So in this calculator, when I want to say do a problem like this, I want to be able to reduce things down. So the first thing I would do is I would start with my radical. So you can see above my x squared here I have a radical. So you're going to hit that square root button and you're going to type in the 281. Now there's a few ways that you can do it. First, you could go ahead down here in the bottom, you could hit your enter button. And in this case, notice it spits out the radical right there. So then what I would do is this button above enter, notice it has these two wiggly lines. If you click that button, it's going to automatically give you the estimate of that answer. So here we're actually going to be able to state that my x value is going to be 2 plus 2 times roughly 16.8 and the whole thing divided by 5. Now in your calculator, I would hold on to this value here and I would do your math. So I would multiply this by 2 and hit enter. Then I would add 2 and hit enter. The last thing I would do is divide it by 5 and hit enter. So we actually have 7.1 as a result. So here, this is actually going to be 7.1, and this is meters. Now, with that being said, what we just found was the width. So here we found W to be 7.1, and we label it meters because your diagonal was in meters. Now if you remember way back from the beginning, we had a statement that said your length was equal to twice the width minus 1. Well, we just found our width to be 7.1. So my length here is going to be 2 times the 7.1 minus 1. So again, this is where, leaving this value in your calculator, you could find your length. So you are going to take that value and multiply by 2 and hit enter, and then add 1 to it and hit enter. So we're going to find that length to be 15.2. So this right here is going to be 15.2 meters. So to totally answer your question, you would have dimensions of length by width. And so in this case, you would be able to say that your rectangle was 15.2 meters by 7.1 meters. And here would be your end result. Alright, now the other problem that I wanted to look at, which is a problem for a lot of students, are these physics problems. So we're talking about gravity and throwing a rock value. So here it says that a rock is thrown upward with a velocity of 50 meters per second from the top of a 150-foot building. So let's take a look at what that looks like. So I have this building here. Okay. And what I know about it is I know that I've got this little rock. So I'm going to draw myself my little circle. And it is throwing upwards, which means it has to come back down. So that's kind of what is going on here. Now, some of the information that we know. We know that you have the velocity of 50 meters per second. So this means that my velocity here is 50 meters per, feet per second. Big difference, big deal. Feet per second. Now the other thing that we know is we know that the building has a height of 150 feet. So here, if we look at it, my height is going to be 150 feet. Okay, that's how tall the building is. Now, the last thing that we know is we know that we are looking for being 10 feet off the ground. So what we're looking for is that right here would be your 10 feet mark. So we are looking for when the ball reaches this area. So the ball is going to keep kind of coming down until it reaches the 10 feet off the ground. You need to use the gravity formula. So the first thing we need to remember is, okay, what in the heck is the gravity formula? So the gravity formula is such that we have h of t is equal to negative 1/2 gt squared plus v naught t plus h naught. Okay, so what are each of these values? Well, h of t is going to be your height. We have g, which is called your gravity value. Now when we're talking about height, sorry, I should have mentioned, this is your final height. T is going to be your time. V naught is always your velocity. And then h naught is going to be also your height, but we call this initial. Another way to think about that is this is your starting height. So we have all of these things going on. Well, what is the gravity value? The gravity value is a constant value. So when we're talking about gravity, we are talking about a value that does not change. So we have either that g is going to be 32 feet per second, or we have that g is going to be 9.8 meters per second. So your units of your problem are very important because it tells you which gravity value you have to use. Now our problem is using feet. So the gravity value for us that we are going to use in our problem is going to be feet per second. Okay, so you need to read your problems and identify those units very closely. So the first thing that we have to do is we have to be able to set up our equation. So we need to know what is what. Well, our final height is 10 feet off the ground. So in this case, we know our h of t is going to be 10 feet. So this is 10. Our gravity value we just stated was the 32 feet per second. Our time is unknown. Our velocity is the 50. So this is 50 feet per second. And then our initial height would be the height of the building, 150 feet. So we just simply have to plug and chug the values into our formula. So we have this formula here that says h of t, so your final height, so 10 is equal to negative 1/2 your gravity, which was 32, t squared, we don't know t, plus that velocity, which was 50 feet per second, again we don't know t, plus your initial height of 150. So if you look carefully, we actually have the makings of a quadratic formula. So in this case, if we reduce this first term, we end up with 10 is equal to negative 16 t squared plus 50t plus 150. And that is the quadratic that we need to solve and reduce. So let's go ahead and look at doing that. So again, we had 10 was equal to negative 16 t squared plus 50t plus 150. Again, with quadratics, the first thing we need to do is we need to set equal to 0. So I need to take this 10 and I need to move it. Since it is positive, that means I subtract. So we end up getting 0 is equal to negative 16 t squared plus 50t plus 140, because we subtract 10 away. And this is the problem we solve. Now, notice I have big numbers, so I would definitely use your quadratic formula. Again, that formula is going to be that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to input our values. So here we've got negative 50 plus or minus the square root of 50 squared minus 4 times negative 16 times 140 all over 2 times negative 16. So let's go ahead again, just like before. We need to take the stuff inside this radical here, and we need to reduce it down. So we've got 50 squared. So this is going to be my 2500 plus, because minus a negative, 4 times 16 times 140 is going to give you 8960. Add in that 2500 and we get 11460. So we can input that back in and we can solve some things down. Now, because we're dealing with time, we can deal with decimals. So this is going to be negative 50 plus or minus the square root of 11460 all over a negative 32. Again, reduce. Negative over negative is going to become 50 plus or minus, and then I would go ahead and just take the square root of that answer and see what you get. And in this case, when we take the square root, we get 107.051, and this is going to be divided by 32. Well, again, the biggest thing we have to note or remember is that time cannot be negative. Unfortunately, we don't know how to go back and reverse time. Therefore, the only part that we care about is 50 plus 107.051 over 32. So being that you did this radical in your calculator, I'd leave that value there. We're going to add 50 to it, and we're going to divide by the 32. And this is going to end up giving us 4.908 seconds. Now, once you kind of get down to the end, this is where you always want to go back to your problem and you want to look at how were you supposed to round. And in this case, we wanted to round to the nearest tenth. So for our problem, we would take this value and we would round it. Therefore, we would state that it takes 4.9 seconds. And this is the answer to what we were looking for. Okay, so there you have it. Two different examples of some quadratic equation formulas that we like to use, and that tend to bother a lot of students. So if you have any questions about either of these problems, please let me know. If you feel like you need to see additional examples or additional problems, please let me know that as well. Otherwise, I do hope you enjoyed, and I will see you around next time.